is all factors of 28. 1 times 28, 2 times 14, 4 times 7. Find A and B. So they have to have both. Have to be found in both. 1, 2, 4, and that's it. Make a Venn diagram. These are not mutually exclusive because they have some in common. Now I probably should have made this a little bigger. The numbers 1, 2, and 4 have to go in the middle. All the other numbers in A that are not 1, 2, and 4 go inside of only A. So that would be what? 3, 6, 8, 12, and 24. And then you do the same thing with B. All the other numbers, so 1, 2, and 4 are in the middle. The other numbers are on just just B. And then all the numbers that are not in either one go on the outside, but still inside the rectangle. Doesn't matter where. So what is that? 5, 9, 10, 11, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, 26, 27. A or B. So I could look at the diagram or I could just do these, but you only want to list a number once, so I don't want to repeat them. They don't have to be in order, but that usually is a good idea to do, just so you don't miss a number. 1, 2, 3, 4, 6, 7, 8, 12, 14, 24, and 28. I could have gotten them from the diagram also. I'm going to draw A, not B, which basically means that. So we draw our Venn diagram. So it has to be both. It has to be inside of A, but outside of B. So that's only 1 out of 4 regions that gets shaded. It's an and problem. That's the first problem. Draw neither A nor B. So basically, that's either this or not A and not B. You can distribute, which means change all of them. So these two are equivalent to each other. So it has to be outside of A and outside of B. So again, this is an and problem, which only means 1 out of 4 regions gets shaded. So it has to be outside of A and B, which would mean it's on the outside here, but still inside the rectangle. Find the number of people. Given. All right, we have 15, 27, and 26 in here, and 7 on the outside. Maybe this is tennis and hockey or something. All right. So find the number of people would be the first question. So we just want to add those numbers up. 15 plus 27 plus 26 plus 7. 42, 49, 60, 75. Now, sometimes people get messed up with probability and number of. Right? This probability would be a fraction, but they're asking for the number of people. Number that have played hockey. So it's not just 26, but we have to add the 27 also. Because the 27 did both. That's 53. Number that played both. That would be the number in the middle, 27. The number that played neither. That would be the 7. And the number that played at least one sport. So we're going to add these three numbers up. Or we could subtract 7 from the total number. It might be easier to do that, or it might be quicker to do that. It might be easier to add the three numbers up. That's 68. In B, we have a circle that has 8 dots in it. And not B has 15 dots. What's the probability of picking in B? There are 8. There are a total of 23. So probability again is a fraction, 8 over 23. Probability of not B, that would be 15 out of 23. We have 30 students. 19 are in physics, 17 are in chemistry, 15 are in both. Make a Venn diagram. It doesn't matter how you label it. Usually it's good to put the first letter down, P and C, but that could be A and B. Usually you like to start with the number that is both 15. All right, I should have made that bigger. Now physics has a total of 19, so there's already 15 here. So 15 plus 4 is 19. So there's your 19 in physics. Same thing with chemistry. We don't want to put a 17 there. There's already 15 in there. So 15 and 2 more makes 17. Now we got to add them up to see who is maybe not in either. So these three numbers add up to 21. There's 30 students. So that means there are 9 that didn't either. Probability of taking both, that's the middle number. 15, the total number is 30. That reduces down to 1/2. Probability of at least one of them, that would be all three of these numbers added up, which is 21. And that reduces down to 7/10. Probability of exactly 1, that would be the 4 and the 2 added together, which is 6 out of 30. And that reduces down to 1/5. Probability of physics, but not chemistry. So only physics, that would be 4 out of 30. 2 out of 15. Probability of neither. Whoops, running out of room here. That'd be the number on the outside. 9 out of 30, which is 3 out of 10. I said this rule, but let's make sure we get it written down. When you have a not symbol outside the parentheses, it's just like distributing, and everything changes, including the operation. Ors become ands, and if it starts out as an and, it would become an or. And that's that section. The last section of the week, we're actually going to spend 2 days on, or supposedly 2 days on it. 2 parts to I. We'll just do the first part today. Laws of probability. The probability of A or B is equal to the probability of A plus the probability of B. But then we have to subtract the probability of both. It's kind of like picking a card out of a deck, like a red king or something like that. The probability of picking a red card is 1 out of 2. Probability of picking a king is 1 out of 13. We would add those up, but we don't want to count them twice, so we would have to subtract the probability of both a red and a king. If the probability of A is 0.6, probability of A or B is 0.7, and the probability of A and B is 0.3. Find the probability of B. All right, a couple ways of doing this. I'll show 2 different ways. We could use the formula. So I'll write down the formula here. And put in what we know. Or is 0.7. Probability of A is 0.6. Trying to find the probability of B. And the probability of both is 0.3. All right. Then what we do is combine like terms. Subtract those to get 0.3. And do a little algebra. Subtract 0.3 from both sides. To get probability of B equaling 0.4. Could make a Venn diagram. The and, try to start in the middle. I got to make that bigger. 0.3 if all of A is 0.6 and this is 0.3, again, that would be 0.3. The OR is these three added up. That's 0.6. Need to get it to 0.7, so that's 0.1. And then the outside would be 0.3 because they add up to 1. And then B would be those two numbers, which again is 0.4. Let's say you are picking a piece of chocolate. And there are 6 hard and 12 soft centers. Excuse me. Pick one. First question, are hard and soft mutually exclusive? Remember, mutually exclusive, they have nothing in common, and the answer is yes, because you can't have both. If we made a Venn diagram, they would be separate. There's no need to make a Venn diagram, but that's what it would look like. What's the probability of picking hard? There's 18 total. 6 of them are hard. That reduces down to 1/3. Probability of hard and soft, again, that's not possible. That would be 0. Probability of hard or soft, well, has to be one or the other. So that's 18 out of 18, which is 1. Conditional probability. Kind of talked about this a little bit already. I just didn't call it a conditional probability. One event has already occurred. A given B. Let's say we have 25 students. 14 like pizza. 16 like milk. 1 likes neither. 6 like both. Pick one student. What's the probability that they like pizza? You got 25 students, 14 like pizza. Probability that they like pizza given they like milk. All right, so the given, when there's a given, that's going to change the denominator, because now we're only talking about the 16 people who like milk. So of the 16, how many like pizza? Well, there are 6 that like both. So 6 out of 16 like the pizza, which is 3/8. The formula for conditional probability is the probability of A and B over the probability of B. So in the previous problem, the A and B was the 6, and the probability of B was the 16. one more example. All right. Given a few things here. Oops, that's probability of A is 0.3. Probability of B given A is 0.6. And the probability of B given not A is 0.1. And they'll give you the skeleton of a tree diagram. So all of this is given. So that's the problem. Oops. That's all given. Letter A, complete the tree. And they'll also say, here's outcomes and probability. All right, so we got to complete the tree. Probability of A is 0.3, which means the probability of not A is 0.7. Each branch has to add up to 1. The probability of B given A, right, so A has already occurred, the probability of B is 0.6, which means not B is 0.4. Where down here, the probability of B given not A, so if not A occurred, the probability of B would be 0.1, so not B would be 0.9. The outcomes would be AB, A not B, not AB, not A not B. And the probability would just multiply. 0.18, 0.12, 0.07, 0.63. Again, those numbers have to add up to 1. Probability of picking a B. So you got to find all your outcomes that have B. That would be these two. 0.18 plus 0.07 is 0.25. To me, if they're going to give me decimals, I'm going to keep them as decimals. So usually I have fractions, but to me it's just easier, I think, to keep them as decimals. You could change them to fractions. And then the last problem, which is a little bit harder, probability of A given B. Now, this one we're working backwards, so you can't just grab the answer like, oh, it's 0.3 because here's another B. So you can't really just grab it from the tree diagram. We actually have to use our formula, which is the probability of A and B over the probability of B. All right, well, the probability of A and B is right here, 0.18. The probability of B we just did, 0.25, and then we can figure that out. 0.18 divided by 0.25, 0.72. Again, we can make it a fraction, but whatever. Everything else is a decimal, so I'll just keep it as a decimal too. And we will quit at that part. The second part of I will do next week, I guess. Then on Friday, we would have a quiz. Make sure you can see that. There it is. Pause it if you need to. And then these are the answers to the quiz. All right. Have a good week.